Hunter. I'm a cloud advocate on the Azure team, and I'm here with the big boss, Scott Hunter.
Scott Hunter, Director of PM on the .NET team at Microsoft.
All right. So basically, we're here to talk a little bit about using .NET Core to build basically anything, right? We've got desktop apps, web apps, cloud apps, mobile, using Xamarin. Obviously, we've got IoT and many other things that you can use. We've got machine learning. If you've seen Scott Hanselman and Seth and the team building our rock, paper, scissors, Spock, lizard app, that was a cool way to do some very approachable machine learning type of work. And one of the things that we want to talk about today is a lot of the work that we've been doing with the microservices work in .NET Core. So today we're going to show you a little bit about how .NET Core can be used to build any type of app. Specifically, we're going to start with some of the cloud development and microservices. So with the move to the cloud over the last few years, the industry has really moved and embraced the microservices and breaking up our monolithic apps into these microservices. We're used to just building these big apps and moving our single assemblies into things like IIS and app service on the cloud and kind of just calling that web service and dealing with that. But now we're moving into multiple languages, multiple services, multiple dependencies that we're having to build on, teams working in different languages, and having to orchestrate all of those calls together. So when we have these large, all-inclusive apps and now breaking up into smaller independent services, oops, let me back up. I need Kubernetes for my clicker here. We want to be able to orchestrate all of these apps and be able to have a good way to make those changes, put them into a cluster, and just kind of have that interloop experience. So .NET Core is really built for the cloud. It's well suited for this type of development. Now, I like to work on my machine locally and just be able to have my interloop development, have my debugging experience, and there's a ton of tools available that we've worked on. And one of the first things that I'm going to jump in and look at is some of the Docker development. But I think one of the first templates, I think, Scott, you want to jump in and look at is the worker template that we've put in here. And what this does is allow us to build some of those services that we're used to having on our machines that were just Windows services. But now we have a new template called the worker template that allows us to build multiple types of services. And I'm going to let Scott jump in and talk a little bit about
Well, I think there's two things. We wanted to also show the...
switch over to your... What number you want?
Number 7. They're not missing anything.
File new project is important.
We were going to first talk about simple service, I think, which is basically an empty file new ASP.NET Core application.
Okay.
And one of the things that, by the way, you're going to see a couple times when we do stuff, this screen come up and say this is because Shane and I are both running preview builds of VS that have a little weird bug right now. We wanted to start with and talk about when you think of an ASP.NET application today, what you really think about is you think about M and the V's and the C's. All our applications have to have models, they have to have views, they have to have controllers. ASP.NET is synonymous with creating UI.
Right.
We do have a web API template for creating APIs, but it still brings a lot of that other machinery with it. It's got routing, it's got controllers, and so many times when you compare .NET to other technologies, they'll say, oh yeah, .NET's got this huge MVC stack, and something like Node.js, you just write 3 or 4 lines of code and you've got your microservice. And so we did want to show that in 3.0, this is what an empty file new application looks like. And you'll notice there is no M or V or C here at all. We're using a feature called endpoints. You can see app.use endpoints. And then inside of that, I can declare a list of URLs that I want to be able to match to. And then I can just say, run this C# code when that happens.
And this is really the simplest form. Actually, you could actually take a few lines of that and actually even make it smaller. Yeah, and this is the simplest form of a microservice when it comes to .NET Core. As Scott pointed out, as we started talking to customers that are like, all I want to do is write a single responsible service that does just blah. Like I just want to write a few lines of code, have it do some work, and return a service. And I really don't care about the views. I'm just a back-end developer that has some downstream dependencies, hit some services on my back end, and return that data to my front-end service. So what we've done here is we've done some work to give us all the dependency injection, all the logging, and all the other goodness that we've had in the full framework of MVC, but not have to have that dependency on the full MVC framework that's there.
Right. So you can write this, and what's cool about this tech is you can also mix this tech with the other stacks.
Right.
For example, I might later on show an example where we have a controller folder, and we have controllers, but in one case, I might want to write a couple lines of code like a health check. I just stick that in right here.
Right.
I don't have to actually wire to that MVC stuff at all. And so we just want to make that very clear that .NET Core is not about just having MVCs and stuff like that. You can go bare metal, turn on as much or little of the stack as you want. And you were saying, Shane, you want me to try the new template.
New worker template, yeah.
So as you think of building a service, we have a new template in VS right here, the worker service. This ships in 3.0, and this was to also address that same kind of thing. How do I build a service in .NET that runs on Linux or runs on Windows? So let's create one of these. And sure, save that, don't care.
Now, how many of you have had a box or a machine that sits under somebody's desk that's its sole purpose is just to run services that run every day on a Friday, right, and do some work? Yeah. So this is a template that we've created that has all of the goodness of .NET Core. It's got your logging, your dependency injection, and allows you to take that type of a code and put it into a .NET Core template. And with a few lines, I think we're going to show some magic here.
Yeah, so I want to call out a couple points again. Number, you're going to see configure services here. That normally is a method in your startup.cs in a typical .NET Core application. You can add these hosted services to any application. So you can be building a web API and add a hosted service to that. You can be building an MVC application, add a hosted service to that. So I want to be clear that all these things that we're talking about are all composable. And so you can see in my code here, it says add hosted service worker, and then here's my worker, and all it is a class that derives from background service, and it's going to have a constructor where we would inject all of those things you said before. We can inject memory caches and configuration, all that stuff, logging that's here. And this is a really exciting service. It loops forever, writing to the log. So it's not super exciting. But I do want to show something here that how easy this stuff is. So I'm going to change that information to warning. And we'll compile this. And Azure Building Services, how do you run a service on Linux or how do you run a service on Windows? And that's going to bring us up to the point of coming over here. And let's just switch this to live packages, browse. See if that internet actually works, Shane.
Now, this works on the generic host builder, so it's just going to host anything that runs on that iHost builder package there. Much like the web host builder, they basically work on the same system. This here just has no web involved, right? So the web host builder just has all of the mechanisms to boot Kestrel, and this here is just going to boot our background services.
So I can make this a Windows service if I want by adding a NuGet package. That's been a big request we've had in .NET Core for a while. And then I might care about Linux as well. And so we have another package out there. And the package is actually kind of cool because it was not written by us. It was written by Red Hat.
Yeah.
So it's written by one of the big Linux distros out there. And that's systemd. That's how you run services on Linux. And so I could do the same thing again. There's systemd. And then we make these things pretty smart, so you can actually add them to any of your services, and if you're not running them in a Windows service or you're not running them on Linux, they just no op, they don't do anything at all. So all I've got to do now is go back to my program, and I can come over here and I can just say .use Windows service, and then I can say .use systemd. And now this application is already set up to run either on Linux or Windows as a service. You could go shove this up into Linux VM and run it as a background task, and it will just run. And it's actually pretty easy. I'll show you how easy this is to do. So I'll jump to a command prompt here. Let's just do we'll go to my source, back, worker service 1, and I'm going to do a .NET publish, and I'm going to set my output to CBAC service. What .NET publish does is it basically publishes the application and all the stuff required for it to work. The -O says do that into this folder, and so now I've got, if I go back to CBAC service, you're going to see that I've got basically all the stuff required for my app to run here. Now I'm going to close out this command prompt and open one more, but this time I'm going to actually right-click and run it as administrator. And I can say SC, let's go back to my service folder here. And I can say SC, which is service, and I can say create. We'll call it my service. And it wants a bin path, which would be CBAC service, my service. What did I call that thing? Worker service. .exe. So all I've done here is I basically ran a command from command prompt that registers a service. SC create my service, that's what I called it. Bin path, press return, it's good. SC start my service. The app is now running, and if I go to my event log and I refresh the screen, you can see right now at our time, yep, you can see the errors or the warnings from the service running. So it's that easy to take any .NET Core code, wrap it up as a worker service, put it into the system, and it runs as a Windows service. So simple.
And we could do the same thing on Linux with the text file configurations for systemd. I could also take the same service and actually put it in a Docker container and run it as a sidecar in AKS, or run it in ACI to do some work as well. But now I can take those applications that are running on your box underneath, Susie's desk, runs every day on Friday, and put it up in the cloud, and now migrate that out there to do the work up there, just with a few lines of code. Hopefully your services are more than just that, but.
And maybe if we have time at the end, I'll show a much more complicated service and kind of walk through how that works. But sure. We just want to show that the worker template's awesome, and it's a great way to build long-running processes that feed from queues or call URLs or do stuff like that for a long time.
Right.
And the stopping and starting of it's all built in the system, and it integrates with all the OSs.
Right.
So let's flip to you and talk about containers.
Yeah, so what I mentioned earlier was I like to work locally on my machine. It's a little bit of, like, I trust my machine, I trust my environment. And we've got some good tools. Again, kind of lower your expectations. I'm working with Preview, so there might be an error. I'm just going to create a new project. I'll just do just a regular core application, nice and empty. You can see this is a new machine because I'm only on web application 2. My old machine is like 2000. All right, so I'll do a new app here. It's going to be super exciting. And there's our warning. And what I'm going to do is first click yes, because we want that to go away. All right. So with any web application, with the new worker template, and other .NET Core apps here, if you have the Docker toolset, the Docker workload installed, and also Docker for Windows installed on your machine, what we can do now is just add Docker support by right-clicking your project file, and now just say add Docker support. I'm going to choose Linux because that's going to where I'm eventually going to work when I publish this. And what this will do now is add the proper Docker file. Pause for effect. There we go. And it automatically knows the type of application that I'm working with. It recognizes that this is, in fact, a web application. It chooses the proper base image for me. In this case, it's going to choose Buster Slim, which happens to be a Debian-based image. It knows it's a web app, so it's going to choose.
You should highlight that in the background, after Shane did this, Docker takes a while, and so the tools are really smart now, and they start actually, even before you start trying to run it or something like that, you see all this stuff scrolling in here. If Shane goes to command prompt, you can see that it's actually creating the container before he's even run the application for the first time, trying to make that first Control F5 actually really quick. The tools have gotten a lot better over the last 2 or 3 years as we try to optimize this.
And I happen to have that base image already on my machine. If I didn't, it'll actually pull that Docker image for you, which is nice too. So it'll kind of warm up your environment for you. If the other thing that happens too now is my debug dropdown, I do have a Docker option, which means I can run this in the container. So if I hit play, it actually fires up just like you were normally working locally on your machine. It's going to go ahead and start up just like you would normally do it if you're running locally in IIS or Kestrel, and launch that application in the browser. And it should take a second here, just like we expect. And waiting, pausing. You'll see on our logs are logging, and we get our application. And this happens to be inside of the Docker container.
So that app is actually running on Linux. It's not running on Windows.
Right.
It's running on Linux on your machine.
And what I'll point out is one of the new features now in this Docker toolset is in the tools on the bottom here, you'll see that we've got all of our environment variables. These are all of the environment variables that are actually inside of the container. It tells me that I'm running in development mode. It knows the URLs that I'm operating on, what version of ASP.NET Core I'm using. This is actually kind of an unknown environment variable that we use in .NET Core. You can actually trigger on inside of your code. It knows that I'm running in a container. I'm using the watcher, so if I'm changing files, it knows what to do. New packages and what the path is, etc. We also knows what ports I'm running on for also SSL and port 80, the logs, and something I discovered today, which is really neat, is I can actually browse the file system inside of the container right inside of Visual Studio. So if you're doing file mounts inside of your application and you're creating file shares inside of your application, you can actually see those files are actually being created inside of Visual Studio and look at those files, which is really nice. You can see the root. You can see all of your NuGet packages. Those are actually being mounted to your local machine, but you can see that they're being copied across. Super nice. Now, as expected, I can go over to my Solution Explorer. I can go into Pages, in my code. Let's go ahead and look at index. And just as we expect here, if I can get this to do what I need to. Not getting there we go, that's what I want. And then if I hit my browser and hit our refresh, we hit our breakpoints inside of the container. So I can develop just like I was developing, quote unquote, in production, and debug inside of the container, which is super great. It gives me that nice inner loop experience. I can make my changes, hit F5, and do all of that. Now I have Docker on my computer, and this is perfect for me, and I can add another service or another project to my solution and continue to work through that inner loop development, even if I had multiple APIs and a web app, maybe a console app, and still work through all of that. The challenge comes in is, what if we have developers who don't have Docker on their machine? And what if if they want to work in a cluster? How do we debug and have that experience inside of a cluster? Scott doesn't happen to have Docker on his machine.
Before we get there, why don't you show how would I publish this? If I want to publish, I've got a container.
How do we get this up to
how do we get to Azure?
App service? All right, so what we have here is I go into my project. We always seem to hide that somewhere. We do our right-click publish. Damien's not here, is he? No, okay, good. So right-click publish. We have options here in a publish target. When we know that you have a Docker file inside of your project, we have a couple of options here. You can go right to app service for Linux, container registries. We can publish to Docker Hub, Azure Container Registry.
If you publish to Azure Container Registry, you would get access to pretty much all the assets in Azure. You can be in Kubernetes, you can be in App Service, you can be in Azure Container Instances. So the Container Registry is kind of the mecca of all the places to publish to, because once you're there, you can pretty much do anything. You could actually, I could even pull it to my machine from the ACR as well. So,
and you can pull it on-prem too. So if you're running Server 2016 or better, you can pull it on-prem too. And that'd be my recommendation is push it to a registry and then start from there. And the ever-present virtual machines, you can publish to VMs as well, or a local folder. So,
but ACR is what we normally would do.
ACR is where I'd want to go. But I could publish those there and continue my development, or we can set up a CI/CD pipeline as well. I think we have that option in another. Hit cancel. We do a project. We should have our build. We can set up a CI/CD pipeline right from Visual Studio as well, and I'll set you up for Azure DevOps.
You switch back to me?
Now, go back to 5.
So I'm in a different situation, and I'm going to show something new. The Docker window that you were showing there, I believe that's new in 16.4 builds.
Yes.
Because I've never seen it before until we played with it a couple days ago. I'm showing a new template that came out in 16.3, and this is called the, am I up yet?
You're on 5.
I'm on 7. This is the container application for Kubernetes. And this is meant to be a template that you can use for building apps you want to host in Kubernetes. And there's cool things about it is I don't have to have Docker on my machine at all. I can do this without any Docker on my box, which means I don't have to install Hyper-V, I don't have to install Docker, I don't have to wait for containers to come down. All that stuff is not required here. And so what I'm going to do is I'm going to create one of these. And there's a couple tricks here. And so I want to show you what these tricks are. So let's do an application. We'll just call it Kubernetes 1. That's fine. And then what it's going to do is it's going to prompt me after that, what kind of project do I want to stick in there? And in this case, I'm building something for Kubernetes. So I'm going to select an API. And I'll click Create. And this is just going to create a regular ASP.NET Core Web API project, but it's going to stick a bunch of stuff in it that makes it ready for, number 1, Kubernetes, and number 2, it's going to turn on a feature called Dev Spaces. This will be the little glitch that you'll see many times as Shane and I talk today. Yep. Okay. So you might also notice that my Run button now says Azure Dev Spaces, and I'll explain what all this means in a second. So my app has got a Docker file in it, just like Shane's had before. There you go. So it's got the Docker stuff pre-set up for it. It's got a chart folder with my app name in it and some files in there. And I might let Shane talk to that in a minute. But now I want to explain what this Dev Spaces up here at the top of the screen is all about. Because this is some magic stuff here. I'm going to click Run. And it's going to come up and ask me for some Azure stuff. Because in my case, when I dev now, while my files are on my drive, what this is going to do is every time that I press save, it's going to copy my files up to Kubernetes in Azure and attach me to that. And so to make this happen, I need to select a subscription. I might steal that Ethernet from you in a second here. In fact, I'm going to steal it right now.
Yeah, go ahead.
Shane has wired internet, and so he's faster than me. Let's make that come up, hopefully. So what this is going to do is I'm going to make sure I do have internet. It appears I don't have internet. Oh, there it is.
There you go.
Okay, here it just came up. So this dialog is slowly loading. It's going to want me to have a Kubernetes cluster, and for fun, I want to show you how you would build this. If you want to replicate what I do, here's kind of the steps. There's a doc link right there. I recommend following the doc link. I've got it open in my browser here, and it's going to start off with like how to create a cluster. You need a resource group. A resource group in Azure is a container that holds all your stuff. And so I would do something like, from the docs, you can actually click this try it button, which opened this command shell over here, and now I can actually just copy that text, paste it over here, paste this plain text, and I could do my CSH group, and I could say West US 2. That'll create my resource group. Then I would actually want to go copy this text. This is going to create my AKS cluster in the cloud. And I would select this to say my CSH group from before. I want to put it in that container I just created. Not a Docker container, but just a naming container. Call it my AKS, that's fine. And I'll set the region again to be West US 2. And I would run that. And that's where I'll skip out of this because this will take about 10 minutes. But I want to show that that's how you get to that dialog, click that link, open this page up, sign in, and you're ready to go. Now, I'm going to close that tab out. And I'm going to go back and actually close out of this as well because I've actually got one of these created already. What you do next, this is important. You create select your cluster. And to me, this is a glitch in the tools. Do not fall for this. It says space default. Do not select that. Bad, bad, bad. You will be very unhappy. Click create new space. And select your space. And then you would press OK, and a bunch of magic happens. So I'm not going to wait for the magic to happen. I'm going to go right to an app that I have on my machine. It's already set up for this. So, and I'm going to show why this is actually really cool too. So I'm going to select my cloud app. And I've already got this wired up. So I've done that dialog box. I waited for the 5 minutes after that dialog box, and I'm ready to go. So you can see I've got what I call my back end. I've got this Azure Dev Spaces. And what we're going to do here is I'm going to click Run. And we're going to see some stuff happen here. So what's going to actually happen here is it's going to go take my application. It's going to make a container. You can see that happening here on the screen. It's running some kube commands to actually put my container up in Kubernetes and get it running. And what's cool is when it's all done, even though it's running in Azure, I'm going to be able to access it via local host. It's doing a bunch of port mapping and stuff like that. And once you get this going, you can actually just change and edit files and save without going through the step again. Wait for it to go.
One of the things that's it's important to note is as we mentioned, he does not have Docker running or installed on his machine, but you'll notice that in the output there, you'll see things like it's pulling images, it's building images, it's tagging images, it's deploying things to his cluster. That's just standard out from the dev spaces in Kubernetes. All of that's happening in the cloud in his cluster. So we're actually syncing the files from Visual Studio. We're pushing them into the cluster. And we're doing all that build, pull, and deploy work actually in Azure and pushing it onto his dev space for him. Right.
So now it's waiting for the container. So it's actually booted a container up in the cloud. It's waiting for the container to start. And once that happens, it's going to launch my browser and stick me into a browser where I can actually hit this API. And then I'm going to show you the next cool part about this. One of the benefits of having all my dev work being in the cloud is my app could actually talk to a bunch of other things in the cloud. If Shane had a project up in the cloud, I could actually have my container talk to his container, and I don't have to worry about copying the container from your machine to my machine and doing all that stuff. We're actually working live in the cloud. Come on, container, please start.
That should be good now.
There,
Yeah.
it's about to come up. You can see it's now saying it's available for port forwarding. And now you can see, notice this, as Shane said, Docker desktop is not running. It doesn't care. And now my API is running up in the cloud. Even though I got a localhost port, we did a bunch of port mapping and stuff like that's going on. And so now I'm actually deving in the cloud. And what's cool about this is if I look in this diagnostic window here, if I go and bring the Solution Explorer up and I make a change to some code, Let's make a change in some code. I'll just add a space, press save. As soon as I do that, all magic's happening. There's a watcher running in the cloud, and it's actually updating my code live in the cloud. Now, let's make this better. So let's go and take the solution. I'm going to add a second project. Add a new project, because that's my back end. It's my API. It returns my weather information. Now I need to have an ASP.NET project. It's my client application. So my front end right here. And I'll select MVC for this. I'm old school. And now it's going to notice that this is the same glitch we have in our VSs. So here's my front end. And what I want to do is I want to make this front end be a part of that same space that I have up in the cloud. So what I'll do is I will right-click on my front end, and I'm going to click Add, and there's this container orchestration support. And I'm going to select Kubernetes Helm. There you go. That's going to add the Docker files, the Helm charts, all that stuff to my application. Now what's really cool is we do a bunch of DNS magic and stuff here as well. So I'm going to go into my controller, and I want to pull that weather from that API that I have up in the cloud. So all I've got to do, and I'm going to cheat here a little bit and just copy some code I wrote this morning. And I'm going to go to my index page, paste that in. I'm going to create a new HP client, and I'm going to change this port. It's localhost. Because I'm running in dev spaces, we don't know what ports and stuff it's actually using, so I'm just going to say my backend. And Kubernetes is going to do all the magic and port mapping to change that for me, and I'm good. So I've got some squigglies here. That's because I need some namespaces. So we'll control dot that. It's going to complain here about the await. We're going to make the method async. It's going to complain that I'm not using the JSON serializer. We'll bring the serializer in. I need weather forecast. I'm just going to copy the weather forecast type right from my front end to my back end. And it should be sitting here at the bottom. There you go. Fix the namespace for that one. And now you can see what I'm doing here is I've got my front end that's going to call my service in Kubernetes on the back end. It's going to call that request. It's going to deserialize that into the weather forecast type. We're going to grab the temperature from the first city and stick that into view data. And I want to do one more thing here as well. Go to my view. Go to home, index. And I'd want to write some code here to show that on the screen. And we'll do it like an H2 here. And I'll grab that value I stuck into view data in the controller, save that, and I pretty much should be good to go at this point.
Save your controller.
So let's save everything. And I'm going to set this as my startup project now. And I'm going to click Run. And once again, DevSpace is going to recognize I've not actually registered this particular it's not a good sign chain.
This might be a minor bug, so I think all you have to do is select your...
Actually, this is the problem.
Yeah, select your... It doesn't realize what it's set up as.
Yeah, so there you go. And now what it's going to do is it's going to take the second application, it's going to make a container for me as well. It's going to put it up in Kubernetes, and now they're both going to be running in the cloud. And once again, I've not done anything local on my machine. I have no Docker, nothing here. I'm developing in Kubernetes live on the fly. And all the things you showed as well work. I can put breakpoints in these applications, do F5s, they'll all work. Once again, it takes a little bit to boot the container up the first time, but once I have both the front end and the back end up, I can just change a line of code up here, and I'll show that in a second. Okay, the container's built. It's waiting for the container to run.
And did all that in 3 seconds. Like, synced the stuff, pushed all his code up there for this new app, built a container, deployed it onto the cluster in 3 seconds. I mean, that's pretty fast. I mean,
and if we're good...
Unquestionable conference internet, right?
And if we're good...
It's taking longer to load the tab. Not that tab. That's the back end.
Back end's running here. I just want to see if the back end is still alive. Uh-oh.
Sadness.
Come on. Come on, cloud.
Questionable back end. Internet. So one of the most valuable things.
Let's start that again, Shane, just for grins.
Yeah. One of the most, the valuable piece that I see in this, quite honestly, other than I don't have to have Docker installed on my machine, is the fact that he just pointed to that back end by its DNS name. I mean, by a show of hands, how many of you mess with configuration settings, like when I'm live, when I'm working on my machine, when I'm working on, Sarah's machine, and I've got XML and any files all over the place, like, oh wait, I forgot to change that, and that's why it's broken. That's the same exact value when I push it to production. It's the same exact value when I push it anywhere else, that I have that one value, right? Now I can also take that chunk of code, now this is just a quick demo, but now I can use, HTTP factory, the client factory for that, right? I can abstract that and set all my values properly for using the client factory the way it should be. It does all the DNS resolutions. There's actually a command line tool associated with dev spaces, and I could run a command called list URIs, and you won't see, my back end. It'll actually give me some very obscure like hash name for what is actually running at in Azure, but we just call it by my back end. And dev spaces actually does all of the DNS routing for you, which is really nice.
It's not like in the front end. Back end is running great.
It's just thinking.
You can see that's the back end right there. We tried this a million times this morning.
Control F5 it.
Just the front end?
Yeah.
Come on.
It's waiting for the container.
That's what it said last time, too. No? Waiting for service to be ready? Come on.
Do you have internet?
Action controller with signature thread. Am I crashing the front end?
I don't know, it's because you chose MVC and you're old school.
Let's,
Do you have the other project you built?
no. I do, but it's not, let's just try one thing here. That'll crash the view, though. Let's just see if it doesn't like that my code. We're gonna run out of time here, Shane.
You have 5 minutes
You want to show something
to
while I'm
land
doing this?
to land it.
How about I work on this and you show something else?
Okay. Let's see if I have internet. Where am I at? I'm on 8.
Yes, I can.
Yeah.
Yeah, basically the debugger, everything works exactly if it was on your local machine. I hear a challenge, so let's.
No, it doesn't matter. Yeah. All right. So, like I said, there's actually a.
Oh, I know
What'd you do?
I know why it didn't work. I'm going to leave the debugging on, but you can switch back to me, Shane.
But I got the command line up. That's my life. All right. Sorry, lost my moment.
Okay, so
No.
let's 7.
7. It's going. It's thinking.
Okay, so let's try to entertain the audience here. Not on my machine. So what I've done is I actually fixed the app. I don't know why we didn't get an error page. I wish we got an error page.
I was just thinking about the error page.
There's the breakpoint in the cloud.
In AKS.
There's my response. There's my model. And if I look at my model here, come on, hover, hover, hover. You can see the types, the stuff. Continue to run it. There's my temp. So nothing's on my machine. Now what's cool about this, as I was saying before, is I'm going to stop the debugger, and I'll control F5 it again just real quick. Because it's looking slow the way we're showing it, but really once you get it all warmed up, it actually is really good. It feels like local dev. And what will happen here is, let's go look. We have lots of stuff now, Shane. I can actually just change source. So if I came to the index page and I said temp equals whatever, when I press save, you'll see in the output window, it'll say synchronizing files, because it will copy that CSHTML file back up to the server. I didn't save it yet. So let's go look at the output of the app real quick. And I made the change to the file. Oops. I need to pin this. And what should happen if I change the stuff here and I save it? I don't know why it doesn't. You don't see the.
You hit Control D, you hit D or something.
I do. There you go. File change detected, updated, completed in 1 second. File change detected, uploading the views. So literally, you can just change your code and refresh your browser and get that kind of development cycle, because it's running .NET Watch in the cloud. And so this is some really cool tech, and we are like 2 minutes away. So
one of the things I'll mention is, you notice that when we create the space, he selected, Scott space or whatever. If he gives me permission on that same cluster, I could create a space on that cluster called Shane, and then I could work on another service, and then I could work on my own space. So he could work on his service, I could work on my service, and the DNS will still just route, and we will not interrupt each other's work. I check in my code, he checks in his code, and we can all just work on our own spaces. Very similar to how branching works in Git, right? And we're not going to interrupt each other. So there could be one piece that Susie works on, and she's doing the front end or back end. We're working on other services, and we're hitting that same service on the cluster, but our specific work is not the same. And we're able to work in these individual spaces, almost like branching. So that's the benefit of spaces. That's our dev space that we create, which is really interesting. So really cool tech. We're still some sharp edges here and there, but it's getting way better, and it's a lot of fun to work with once you get into multi-team, multi-service type of development when it comes to Kubernetes. And nothing on your machine, it all happens in the cloud.
please try this and give us feedback.
Yeah.
You're out of time.
We are out of time. We've got some resources. Where are we at there? Is that number? That's this one.
That was 5.
That was 5. So just some real quick things. We showed some stuff at .NET Conf a few months ago about the weather app. It has a lot of the tech that's there. Check out a lot of these links here, health checks. And then just a little plug, Cloud Native Show. We did some filming. We talk a lot about this tech with the engineers that build it on campus. So check that out at that last link. And if you have any questions, we're available. Thanks.